Good evening, good evening, good evening, and good evening to you, ladies and gentlemen. WeatherBrains episode number 785 for the 1st of February, 2021. It's the magical time of the program where we share three things during our pre-show: boring personal stories, humorous anecdotes, and we say outrageous things occasionally. So we'll be starting the show here in about 15 minutes. We're opening up the pre-show a little early tonight. So if you want to see the actual program, move the slider about 15 minutes in, and it begins there. But you might miss some good stuff here, okay? So as we do the show this week, we have all kind of things going on. We have first off, a major high-impact snowstorm for the Northeast United States, New York City. Central Park, the last time I saw, they had 18 inches so far. And this thing is far from over. And it sure looks like parts of the Big Apple will have 2 feet of snow from this. That is a whopper for them. Of course, we'll be talking about that, obviously. But anyway, let me get the embed code down here and get our guests on. Guess who's on the show this week? We have the director of the National Weather Service. Dr. Louis Uccellini is going to be on the program tonight. So we got a lot to talk about, but let me bring in our guests and we'll get this thing going here. Yeah, last Monday night was interesting. If you missed it for show 784, we had the threat of severe weather going on. And down here in my market, and boy, did we have a severe weather episode right after the show. We had an EF3 tornado that blew through the northern suburbs of the big city here. And fortunately, one person was killed, a 14-year-old boy. And obviously, a lot of people were injured, but that was a really rough night. And we might talk about that a little bit tonight. Fairly interesting case study in terms of how the warning process worked. And again, I think it worked okay. There were some issues, technical issues, and we'll talk about that as we go. But again, good to have Louis on the show tonight. We'll get an update on what's happening at the National Weather Service from the tallest hog in the trough. And here comes Mr. Murray. Mr. Murray's appearance brought to you by Peloton, the bike of choice for the new generation. So, Bill, I think you should get on that thing and show us what you can do. And he's frozen. I think Bill's on his 300 baud modem tonight. Hello. Hello, hello, hello.
There we go. Trying to get my AirPods to work.
I'm getting about one frame every 10 seconds.
That's going to be trouble because I rebooted this computer 15 seconds before you sent the invite.
Looks like a bandwidth issue.
I got 100 megs down and 100 megs up. That's crazy. That can't be. This will not work.
Sufficient.
I speed tested it, right? Let's see what's going on here. I mean, there's nothing running this computer but Zoom. I even closed my email client.
You ain't got to do that, man. I do, weather on TV. I got Wirecast. I got everything open. I don't close anything.
Well, but I've found recently that, I'm having issues if I don't reboot the computer and, get everything kind of pristine. How about now, James? I got 88 megs down.
Your audio is okay. Your video is coming in about one frame every 10 seconds.
Yeah, I see that.
30 frames per second.
Let me get do the invite again one more time. See what happens.
And he went away. Bill's on his 300 baud modem. You don't see a lot of those anymore. But no, last Monday night, in fact, I was really not on the show. And I actually enjoy that in a way, because when I listen, it's almost everything is fresh. And I listened to these later, the audio version, and we had Jeff Craven on last week, and very interesting discussion about the national blend of models and probabilistic versus deterministic forecasts, and just stuff that we're kind of grappling with here in the forecasting business. So if you missed it, we've had some amazing shows here lately. I mean, we've had, goodness, some really good ones. We've had Tom Skilling was on recently. It's just been the guest booking officer needs to quadruple his pay.
4 times 0.
Yes, there you go.
How's the audio, James? I see this video still not good.
Yeah, your audio is fine, so we can live with the 1 frame per 10 seconds.
Yeah, I'll just sit really still.
Yeah. What kind of connection for your camera do you have there? I mean, what's the connectivity? Because I think we have the same setup. I have a Logitech StreamCam USB-C straight into the computer.
I'll swap to just my Mac.
All right. Hello, Jen.
Hi, how are you?
But Bill's on his 300 baud modem tonight, so we'll. You don't hear about not a lot of folks use those anymore, but
it's the StreamCam, James.
Classic.
It's the StreamCam.
Yeah,
Hi, Jamie. It's good to see you.
Hey, Jen, it's good seeing you too. How's my audio coming across?
Good.
Loud and clear. Sounds good.
I'm going to run from the AirPods. Is that okay, James? Can you hear me
what
okay?
Now?
I'm going to use the AirPods as the microphone.
That's fine.
Yeah, because I don't want to have to rip all that stuff out of the docking station. It was the StreamCam. That was the whole problem.
I've never had a problem with mine. I use this thing on television. I mean, I've had people. It looks better than some of the studio cameras in the studio. Almost, it looks better than the one they use in the newsroom over there. And I think this was $300 or something. Times have certainly changed. Louis, can you hear us okay?
Am I on?
Yep,
yes,
there you
sir.
are, Dr.
You are loud and clear.
Touchdown. All right.
Touchdown.
Let's all quit and go home.
I bet you Louis done so many Zoom calls he could write a book on them all.
No, Zoom. Remember, we.
Oh, that's right. The weather service.
Yes, you better watch out, Dave. So disconnect.
Yeah. We can't initiate a call. We can join one now. That's why we're able to do this.
Okay.
So.
Well, that's good. Yeah, I remember back in the early days, we had to use Google Meet, and it makes no sense because Google, you can't stream on YouTube from Google Meet, and it's a Google product. We never understood that, where you can stream directly on YouTube from Zoom. None of that made any sense. But anyway, we're all good here. See, Troy is with us.
Dr. Yu.
Hey, oh my God! Oh, this is gonna be a rough night.
This show is going right down the tubes. Right
is your internet about to go out, Dr.
Yeah. Louis, at least you I have respect for. Okay, no, I'm just kidding.
show title. All right, so we're 5 minutes early. Goodness, we'll wait till the top of the hour to start the show here. Kim Cloco McLean should be with us here. Is Nate coming tonight, Bill? Do we know?
As far as I know, I haven't heard anything to the negative. So we should have a Hollywood Squares.
Ooh.
You're Paul Lind, Louis.
Yeah, you are. Louis in the middle of mine. See, hardly any of us know or are old enough to know who Paul Lind was. I'm one of them. I
Yeah.
remember
Yeah,
Hollywood's.
he was a funny guy.
Yeah.
Yeah.
Yep. Well, I
John,
even
you
I
say-
ran to something else, James, and I know Louis will appreciate this. Bill, you will, but I think everybody else, Jamie, probably not going to happen here. But I will tell you what I ran to today. I was talking to Daryl up at Iowa State, and what I wanted to find, Louis, was the first, well, not really the first, but I wanted to find the last of the 3-part, get this, James, of the 3-part national weather summary that the National Public Service Unit issued out of Kansas City. I actually found them today. They're available in the Iowa State in their text data. The last one was April of 1994, April 2nd. Found
Please
the
tell me
last
that's your
one.
pick of the week, Troy.
I know, and it's amazing. Daryl found it, and the National Weather Summary, the National Public Service Unit, Kansas City, Missouri. So.
Yeah.
Awesome stuff.
There's a political story behind that, of course.
Yeah.
No.
Oh
Yeah.
boy.
Ask that on the show.
No, it was the first drive to really start offloading products from the Weather Service. It was in that era where they were looking for us to offload things to the private sector, not just facilitate the growth of things, which is where we came to with the Fair Weather Report.
Yeah.
So that's why that, and some of the other products too, was all related to the election in 1994, actually. So, but we're in a good place. I'm a big fan of the private sector. So
I agree.
Yeah.
But I just I'd gone kind of looking for that. I'm trying to I'm going to get it here so that y'all can see it. I'm putting it into the chat right now, and believe that is actually the first one that he has in the database. 1983 will be part 1. If you remember, the National Weather Summary came in 3 different parts. The first was a narrative, Louis, correct me, and the second was a discussion of what for today and the map detail, and then part 3 was the map forecast for tomorrow.
Right.
Yep.
And then we did the selected cities list was put out separately.
Yeah.
In fact, it's still done, and that's what got out to everybody. I mean, it was every newspaper you would open up.
Yeah.
And it's pretty clear. It's a very efficient way. We could just do it now. There's really no big deal. But the local papers, others that can't compile that, it's still one of the favorite products that comes out of WPC.
And it's still published. I mean, that thing's put in newspapers all over the place that I see.
All over the place.
Yeah. But and I was looking for one thing, Bill, and James, for you as well. There was a product in the southern region. There were 2 of them back in the day that was part number 4 to that, and it was called Additional Details for the 5 South Central states or the 7 Southeastern states. And Birmingham and Memphis put it out for Alabama, and then Fort Worth and New Orleans put it out for the South Central states. But Daryl and I can't find that one.
So the Weather Service in Huntsville has their IWT tomorrow, and they sent a background. They sent a background, since we can't do a group shot. They wanted us to get a still photograph with their background so they can do a composite for everybody that's in the IWT. So this is the Huntsville IWT publicity photo for James Spann tomorrow. That's a good look right there.
That's amazing.
It's Groundhog Day, so
it's Groundhog Day. That's right.
So I'm excited. I think we're gonna have a great time. I love IWTs. I've participated in so many of them over the years and traveled to a number of them and had a chance to speak, and they're just outstanding. Really, really good. So we'll be doing that tomorrow, but I think we're at the top here. Kim, how are you?
Hello, everybody. I'm doing really well. Just got the kids down to sleep. So
Yay.
yay. Yeah, very, very excited to be here with you all.
How you doing,
Awesome.
Kim?
It's good to see you, Dr. Uccellini. I'm doing wonderfully.
Great.
How are you?
And Jennifer, have I met you? I've been meaning to say hello to Jennifer. I don't remember meeting her before.
I don't think so. Nice to meet you, sir.
Nice meeting you.
All right, here comes Nate Johnson. So the gang is all here. So let's get this
Wow.
show started. Here we
All
go.
right.
And the party's all here. Here we go in 5, 4, 3, 2, 1. WeatherBrains episode number 785. This is the weekly show that's all about weather. This is for the 1st of February, 2021. As we are getting deeper into the cold winter. And woo, man, it's going to get cold. Goodness gracious alive. Jen, how cold is it in Ohio tonight?
It is 23 right now. I am not looking forward to Sunday, Monday with the
Mhm.
Arctic plunge coming in. I think our high on Monday right now is projected to be 9
Degrees.
at all. And we have 9 degrees. Yes. So not interested.
Head back.
But we got
How
some
much snow? How much
here
snow,
and
Jen? How much snow did you get?
About 6. It was 4 inches Saturday night, Sunday morning, and then we had just little bits that have lasted because the storm is so slow to move out. Probably a few more inches. I did not venture out today, but I would say probably another 1 to 2. So good 6, 7 across West Central Ohio.
Awesome. I see Nate Johnson, the bearded wonder, is here.
Oh,
Dr.
nice.
Johnson, you
Switching
were the,
cameras and everything.
I know.
the head of the NWA, AMS. What else?
NBC?
NBC.
all these, all these
three-letter
abbreviations.
The
I don't know if he'll
NCAA. I
claim
mean,
that.
what? Goodness gracious! I mean, the man runs everything these days.
Run nothing. I just try to keep up.
No, you're kind of a
Heard
big
that.
deal.
Oh no.
Nate has
I like
many
being-
leather-bound books, and his home smells of rich mahogany.
Oh, and actually I had to buy the pillow. I had to pay money.
Yeah.
They didn't even give you the
You had to
peacock
buy
pillow?
that.
I got a discount, but I had to buy the pillow. But what you do, you got to represent.
Okay. So how is WNBC doing with the snowstorm tonight?
Doing well. Had 16.3 inches of snow, I think, as of 7 o'clock at Central Park, placing this 17th in recorded snow history there, and we're still piling it on, as it were. So a lot of fun with our team. We've had a sort of a live chat in our internal chat stuff going since really Saturday afternoon, back and forth, and all the way with all their Mets, all the way from DC up to New England, and it's been a lot of fun to work with them on this snowstorm and to see how they're covering it.
I bet.
Guessing it out.
Dr. Cloco McLean, how much snow do you have in Norman, Oklahoma tonight?
Absolutely none. It's been beautiful. It's been sunny. The sun finally came out. It's been a while since we've seen it here. But yeah, we were in the upper 50s today, and I make you all make me feel a lot better about being at 43 degrees right now. It's not bad.
Let's not forget, you had piles of snow as the season started. So you
Right,
had
we had
your
a really
share.
early entrance into winter. And October was not a pleasant time for Central Oklahoma. It took us a long time, over a month in some places, to really recover from the ice and snow we did get. Now, if we got the cumulative ice and snow now, it wouldn't be as big of a deal because, of course, the trees don't have leaves on them. Just showing you how impacts are so seasonal. But yeah, we certainly did have winter already here in Oklahoma.
Indeed. Troy, deep in the heart of Texas. What's happening?
Louis has most graciously loaned me the Austin Great Hills Co-op MMTS, which I have here, which most trustworthy tells me it's 45.2. So that's what the co-op has at the moment. Skies are clear. We kind of interesting. You may have followed the dust, Kim, that came out of West Texas over the weekend, actually right over the Austin area Saturday night about midnight with the full moon, which was really impressive. And actually Bergstrom Airport, the contract weather observers out there reported blowing dust. So at midnight. So that was interesting, but next 7 days look quiet and we move on.
And we thank you for the dust from Texas because we had it yesterday.
Really?
Yes. I mean, it's just, I don't know where it is today, but we enjoyed some of that West Texas dust yesterday behind the old dry line. But Bill Murray, we've got important business. We got to bring our guest on here before they bolt for the exits.
If they haven't yet, maybe they won't. So tonight's first guest weather brain appeared recently on show 773. That was only on November 9th. And Jamie, do you remember the title of that show?
I don't recall the title right offhand.
Well,
He
it may be
successfully
appropriate.
blocked it.
Yeah. Old Men Cry Easily. That was the name of that show.
And to clarify to Louis, who wasn't on the show, I wasn't talking about you, Louis.
And truly, as our show titles go, that's pretty tame.
It really is. That's one of the better ones. Yeah.
Of course, I'm speaking with Jamie Morrow, who's the executive officer at the National Weather Service headquarters. Tonight, he brings back his boss for a little fun. He didn't get enough the first time. But Jamie, welcome back to the show.
Hey, thank you so much for having me, and thanks for having me back so soon.
Well, we're thrilled to have you back, and looking really forward to tonight's show. But tonight's main brain is NOAA's Assistant Administrator for Weather Services and the Director of the National Weather Service. And of course, in that role, he's responsible for all the day-to-day civilian weather operations for the United States, territories, adjacent waters, and ocean areas. Dr. Louis Uccellini, welcome back to WeatherBrains as well.
Thank you for having me.
Very few people get applause.
This is my second time too, so I guess I'm catching up with Jamie, huh?
I don't remember what the title of your show was, but it's been 356 shows since we talked to you, Louis. That's a long time.
Yeah, well, I certainly, I think I told you the other day that I felt like I was coming out of my second PhD oral exam. Yeah, you covered the whole range. It was really.
We have nothing left to talk about tonight.
Well, it's been a while, so.
After you said that, I went back and listened to that show, and boy, we did cover a lot of ground that night.
Very pointedly, too.
Oh, really? Well, I didn't remember being pointedly.
Well, there was a lot of things going on back then, and we were fixing a lot of the infrastructure, still working on infrastructure issues, plus launching, a whole new approach to our jobs, which was, going beyond the forecasting warnings to connect with decision makers. So, and I think that's been working really well, exceedingly well, actually. So. But anyway, it was still I love I love those kind of challenges, but it was really a great time. And when I watched the show, you guys have a lot of fun with it. You really do. Yeah. I mean, it's really really genuine. So
we sure do enjoy it. Well, if that was like a PhD dissertation defense, this will be like maybe testimony in front of Congress. How about that? Will that be okay?
Guess I asked for that one, huh?
No. But we had Tom Skilling on, as James said earlier, a few weeks ago, and you and Tom were together at the University of Wisconsin, weren't you?
Yes, we were. I was going into graduate school when he came in as an undergraduate, and we all met up in the fax room. We spent a lot of time in the fax rooms in the evening. If there was something big coming on, you would not want to miss any data. We collected all the data for our synoptic labs, and some of the times we were plotting cross sections, surface maps, the whole 9 yards, so that we would be, when we were in a synoptic lab, we would have that data in a sort of a time continuous way from 12Z to 0Z to 12Z. So there's a lot of good times in that fax room, and I would claim that we learned just as much there as in the classroom. We got to practice what we were learning. It's really tremendous. So Tom was there. Of course, we had Bob Gall, who wound up at NCAR, and others that came through the university at that time that really made for interesting. Let's say we argued more than we discussed, and then we learned later, right? But it was really an amazing experience, that whole fax setup that they had and what we did there.
Well, we had Steve Weiss and Roger Edwards a couple of weeks ago talking about Bob Johns and his amazing career. And we sort of degraded into this, talking about teletypes and fax machines. So I'm sure you've got a funny fax story or teletype story you could tell us, something that nobody's ever heard before.
I don't know how much you know about these fax machines, but they got these wires on them, right? That actually transmits the signal to the moist paper.
Yep.
So if you didn't want to miss a surface map, or when the LFM started coming out, you know, as crude as it is by today's standards, you did not want to miss those model runs, because those were the first model runs that actually had precipitation on one of the 4 panels. Otherwise, you were just getting a surface and a 500 millibar level with vorticity on it, and you had to assume where, you know, the precip would fall based on vorticity advection. So you didn't want to miss those. So we would be in there. I knew how to change the wire if the wires looked loose, or, you know, we were worried about it, or if it actually broke. We get there. We made sure we get there early, change that wire, make sure we had a new roll of paper on it if the old roll appeared a little dry, because it would rip from that wire. So you had to know how to do all this stuff just to get the 12 and 24-hour LFM. And of course, this, you know, the teletypes are clacking off on the side, and people are plotting hourly maps, and that's how I got into the gravity wave study, because nobody, and that was the case, nobody could figure out what the hell was going on in Iowa. So I wound up doing that for my master's thesis, and that was my gravity wave. So everything, you know, all the research I did coming out of Wisconsin, and even when I started at Goddard Space Flight Center, was all done with operational data. It was all started, you know, in the fax room. The PhD thesis on coupled jets started in the fax room. The gravity wave paper started there. That was my master's thesis. And it's amazing the amount of data you had to work with. And you could count on NCDC to get, you know, whatever you needed to have sent, you know, in terms from an archive. And yeah, if we couldn't answer the questions, if the folks who were ahead of me couldn't figure it out, and us younger ones were just arguing with each other, I figured I better dive into this and find out what's going on. So it's a great place.
So, yeah, we listening to Tom, it seemed like it was a pretty heady time with satellites just really coming into their own, and, you know.
Yeah. So at the university at that time, Sumi, of course, was doing his thing with the satellites, but he's also, you know, inventing Mercatus, which was the first interactive system that you could view the satellite data in real time with. And so that was, it wasn't up on the 14th floor where the fax room was, but you could go down to the 6th floor and start looking at the real-time satellite data. They eventually brought that kind of technology up to the Synoptic Lab. But yeah, we were being exposed to all that. Numerical modeling was producing operational maps that you could actually look at and compare to the barotropic and the baroclinic progs, and figure out what we were gaining from the, you know, getting the full set of primitive equations, displayed products that we were up to that time just approximating what would be going on based on, you know, the vorticity advection and the temperature advections. And when I was in the school, that's basically all you had starting off. So when the LFM came out, limited fine mesh model, in an operational framework, it was a stunning experience to be able to see that.
So, and it probably was a very interesting time politically to be at the University of Wisconsin.
Oh, it was. And of course, you know, the anti-war demonstrations were going on. It developed a reputation for being the Berkeley of the Midwest. One of the things that's interesting was that in talking to some of the professors, not all the professors enjoyed that environment. Some of the professors would tell you that they really enjoyed teaching during that period, because even within, like, let's say in the meteorological classrooms, they felt like we were asking more questions. We were more engaged with them as professors. And, you know, when I started going back there and interacting with students, the laptops were coming in and things like that, and people seemed more isolated in the classroom, you know, doing everything on their laptops versus what we were doing. And the professors, you know, really try to draw you out in an argumentative way in the classrooms, in the synoptic labs, for example. And we jumped at the bait. You know, we weren't shy about it. And they Lyle Horn used to say, he's one of our favorite people there. Actually, I felt he was like the soul of the department because he spent a lot of time with students, that he really enjoyed it, as given all the interaction that we had in the classroom. So, but it was an interesting time, no doubt about it. You just work through it.
So what'd you do first, Lou? What was your first job out of college?
Well, I did a postdoc there in Space Science and Engineering Center with Sumi and Don Johnson, my PhD professor, was working on the 3 papers out of my PhD thesis, and then went to Goddard Space Flight Center. When NASA Goddard was establishing a laboratory for atmospheric sciences, Dave Atlas was the head of that, and it was a severe storm branch that I joined up with. And at that time, Milt Hallam was spinning up the global group. So people like Eugenia Kalnay, Michael Gill, Shukla, Dave Randall, Colorado State, Bob Atlas, who I shared an office with. They were there, and an exciting place. They were developing the global modeling and getting satellite data into it. Then Joanne Simpson came in as the branch chief for the severe storm branch. I got to work with her for over 10 years. And tremendous lady, really, had experience in the federal bureaucracy. Basically the vision plan follow through. We have to have a strategic plan. We have to have a tactical plan working off of that and follow through on it. And I carried that mantra with me: vision, plan, follow through. Joanne really pushed that, and we got into a lot of things. Science first. The data will follow, the satellite data. That was a mantra they used, which was unique for NASA. We did get involved in mission. I was the VOS demonstration scientist there. And then I started writing some papers on R2O, research to operations. And I got to know Jim Hoke, who was over at NMC. And in one of the workshops, we were going to these workshops, it was the Cyclone workshop. He came over to me. He says, Louis, if you want to write R2O papers, maybe you ought to come over and learn a little bit about the O part. Because what you say sounds, reads well on a piece of paper, but you ain't gonna, experimental forecast facilities and things like that. You better know what you're talking about if you want to plug into it. And I got to thinking about it. So position opened up at NMC in the operations division, running the meteorological operations division, and Bill Bonner and Ron McPherson hired me to do it, and never looked back. Never looked back. So that was my entrance into the Weather Service in '89.
Yeah, so you were after the hiring freeze, I guess, by that time. We've been hearing that hiring freeze a lot lately, right, Troy?
Well, in '89. We had hiring freezes in 1981 at NASA that we got people in just before, like Paul Cosin, Dan Kaiser, Ralph Peterson, people like that who came and worked with me. I never said they worked for me; they worked with me, and in the section that Joanne allowed us to spin up, and that was interesting. That was an interesting experience, but the hiring situation always comes and goes, and I was quite fortunate actually that Ron McPherson and Bill Bonner had confidence in me. In fact, I often asked them what were they thinking of hiring a researcher to come in and run the largest operational group in the Weather Service at the time. It was the Meteorological Operations Division in NMC, and Bill Bonner was pretty funny. He recently passed away, unfortunately. He's a really great guy. But he said, I had you pegged as being a future director of NMC, at the time it was NMC, or the National Weather Service. So after I got NCEP and then the Weather Service, and he was at a party, and he said, I didn't really think that you'd be both. He says, but I got a twofer out of that recruitment. So, but they had a lot of confidence in me, and I have to tell you, that it was a brave decision on their part to bring somebody in, because running an operations division, you've got to be all in. And, you know, I was clearly writing lots of papers and doing research and you know, enjoying myself in the research community. You go over to a 24/7 unit and you better be all in, because the people working for you are depending on it. And then you realize the importance of the information you're putting out. There's a lot of people outside the four walls of that building are depending on it also. And that puts you in a different tempo, different pace. And now, you know, with cell phones and everything else, you know, you're always locked in. You know, you can't, I claim there's downtime, but you're always tethered is the word I use, you know? So yeah, Jamie's shaking his head up and down. When I'm tethered, he's tethered, right? So he knows. But it's you got to be all in if you're gonna you know, go into the operational world. And of course, people who are working shifts on 20, you know, they're rotating shifts and are dealing with that to keep us going 24/7. They, you know, they're all in. You know, there's no question about it. Well, the people supporting the field are all in too. I can attest to that.
So you mentioned that those folks inside the center are counting on you. What are some of the main ways that someone might not think about and how that's important?
Well, it's the stuff, the less glorious stuff, like, you know, at the time in '89, we were having trouble getting products off the floor. You know, back then we had these big maps, surface maps. You had to put them through one of these Uccellini machines, this ammonia type machine that would make the copies to get them out. You know, within the building. Some of the you know, when you had the fax, of course, you had to go through the fax circuit, and then they went to AFOS, and that actually eliminated some of the products. You know, we couldn't get a surface map out over the out of the AFOS. That was why the surface map used to be the most important map in their operational unit. The surface map was the beginning of your forecast process. So when this meteorological operations division was spun up after World War II, the surface map became like the center of the operation. But they were big, right? You couldn't get them on an AFOS machine. So it started losing their importance, and regions, you know, individual forecasters started doing their own surface analysis as part of their whole cycle, you know, on a shift. So, you know, things like that. How do you keep on getting that information out? The big challenge for me going into MOD in '89, it was a completely analog center. There was no digital aspect to it. Zero. Unix was coming up in all the research community. No Unix systems, all proprietary. I won't say the names of the systems, but they were all proprietary for whatever was starting to be done digitally, right? Drawing a map on a light table rather than having a MetTech copy it and getting it on an Uccellini machine. So we had to introduce Unix. We had to introduce, this is where the AWIPS, the centers weren't part of AWIPS, so we had to get a digital system over. That's where we brought GEMPAC, and it became NAWIPS, the National Centers version. And then we started building that capability up. And finally, I think it took about 5 or 6 years where we can get everybody onto the NAWIPS and get all our products generated on the screen and then released digitally. That started happening in '99. So it actually took 10 years. It took 10 years to get it, you know, all in. So that was the challenge we were facing, but it created efficiencies, and it allowed us to restore some of the products that had been cut, because the old way was labor intensive and couldn't keep up with them. So some of the surface maps dropped out, the 9Z map, the 21Z map. We restored those because we were doing them digitally, and you could do your surface analysis. You could start with the previous analysis and start adjusting it. You could start doing things that you couldn't do in an analog mode. So those are the kinds of things we were working on. But just keeping it going, making sure systems would run. It was a tough job. I mean, it wasn't, there was a lot of old equipment there. Let's just put it that way.
And you still had time for meteorology in there. That's what.
Yeah, writing review. Well, we're still working on some papers coming out of Goddard. I was told I wouldn't get paid for writing papers, so did them at home. Did a book with Paul Cosin. Started that at Goddard Space Flight Center. But yeah, that one we started in '94, and it took 10 years to get that done.
How come I didn't have you autograph this for me, Louis? I think I bought it at AMS, or maybe I already had it. How I got out of that without an autograph, I do not know. You mentioned Joanne Simpson for a minute. Talk about her, because you talked a little bit about how astute she was, but any other cool Joanne Simpson?
Oh, well, yeah. So, one of the fortunate, I had Charlie Anderson as my master's thesis advisor. He was the first African-American, first Black person, I think, in the world to get a PhD in meteorology. He was in the Tuskegee Airmen Group, as a meteorologist, because he wanted to be a flyer, but his eyes he couldn't do it. So he got, with his engineering degrees, he went into meteorology in World War II. And then he came out and got a PhD in MIT. So the experience with him was really incredible. But he never really talked about what he had to go through. You learn about it later through his personal interviews, what he went through to sustain himself through that journey. Then when I went to Goddard, Joanne Simpson came over. Of course, I heard about her. She actually gave a talk at Wisconsin while I was a student. She's the first woman to get a PhD in meteorology in the United States, not in the world, in the United States. And she got it under Reel, but Rossby was in the Chicago school. And she and Charlie were in the same class in '43 in Chicago when they were coming in, trying to get meteorologists for support World War II. And then she left and then came back to get an advanced degree. And there was she went through a lot. She talked a little bit about it at Goddard, and the book is out now, First Woman, that really shows what she went through. And she did it on her own. There was no support group. And so if I went in there and whined about something, she'd sit me down and, say, this is, it's especially if somebody, the review process wasn't going right or something, she would go into one of her stories, but she always came back to what it takes, to get over that, to how to address the criticisms in the review process. Some people don't get that kind of advice. And of course, she was very committed to the AMS. I joined the AMS very early in my career as a student. And so seeing how committed she was not only to us and to Goddard Space Flight Center and to the NASA mission, she became the trim mission scientist after I left. That she was no longer she was like moving on from the branch head position to be the trim project scientist. This was, she just kept on going. She's just right, and accomplished an incredible amount, deserves all the recognition that she's gotten. And she served as a mentor to many of the women who rose up behind her. She was very supportive of their career. So she's a real role model for a lot of people, and including, you can talk to any one of us that were in that severe storm branch, and I had 25 people working for me, contractors and civil servants, and every one of them will tell you what a remarkable person she was. So. And
yeah, that I can't wait. We need to have the author of that of the book about her. But we had the filmmaker who did the great American Experience on Fujita, which I'm sure you enjoyed.
Right.
And he shared a lot about what Fujita went through, and some of his research being rejected, and how tough that was on him. And so maybe he needed Joanne Simpson to pick him up.
Yeah,
and
well,
dust him
see,
off.
well, Fugino was really. I saw him in action too, and of course he was a finder through the observations again. This is where, he would the incredible detailed work that was done and the painstaking work that he did it, just to set up getting all this data together and then doing it. I mean, he could probably visualize, how the air flew, went through a thunderstorm just based on all of the data he was collecting and what it must. So when he's seeing these double vortices, he said, you got to have multiple vortex tornadoes. And no, and then finally, all of a sudden people are taking pictures of them and showing them, right? The downburst, that was, I didn't know this, but, learned it by watching the show and then reading this magazine article that was in the University of Chicago press about how he was seeing damage patterns from the one of the nuclear weapons, explosions in Japan. And, so like right near the middle, there were some things that were still standing, after the nuclear bomb. So they figured out where the bomb exploded, and right underneath it, there was things still standing, but off to the sides, in a circle, everything was blown away. So when he started seeing some of these patterns in the trees or the fields that were knocked down by one, he said, wait a minute, I mean, this is an intuitive, visual genius. Now, when he got into some of the cause and effect things, that's where I think he started getting into some trouble. But he had the last word, clearly, and the work he did for the 74 case, to map out all those tornadoes and to show the clusters and how nobody had ever done that before. It's just amazing what he was able to put together for that type of storm system.
I think every panelist on this show has a copy of that map in way, shape, form, or fashion. But you mentioned being, Joanne being actively involved in the AMS, and you too, obviously. But you were a charter member of the NWA, right, Louis?
Yeah. I was found out about it. I think her name was Fred Parmenter, was one of the co-founders. She was a visitor. She wound up in NESDA. She was one of the visiting NOAA. NOAA had a program then where they would send people to school for 2 years to get an advanced degree, usually a master's thesis. And she was there, and she saw some of the work I was doing with jet streaks at the weekly stand-up. I was, again, from the operational data, a poor man's isentropic map, you can do that and then show how these are coupled, how the, and especially the low-level jet being in the exit region, case after case kind of things, gave me confidence of what I was working on the case that I chose for my PhD. And she just came over and asked me if I wanted to join this organization, that the operational people felt like they weren't getting the recognition within the AMS and their issues addressed. And they decided to form their own group. And I said, sure. Now, I had no idea that, like I said, in '89, this is like 14 years later or whatever it was, that I joined the National Weather Service. But I was always interested, even as a kid, in forecast, the forecast, and how could they be right and then be wrong, and why is this, or how can they forecast snow for us and we get rain? I mean, how does that work, right? So the thing is, I just instantly said yes, and I signed up and paid. What was it? Somebody made a crack about it because the dues are right on the card. It was somebody made a crack about how low the dues were, and but I've been there. And then the first article that was published in the National Weather Association was the stuff I was doing that she was interested in, on the using the operational data to do an isentropic map and show these jet interactions. Was the very first paper published in NWA.
I know Nate can speak to the, yeah, exactly. Yeah. I know Nate can speak to the fact that the the NWA really appreciates the support of the National Weather Service, Louis.
Yeah, and we really appreciate their efforts. And I wouldn't say on our behalf, but just their efforts, because it's very clear that what is being done and has been done in the operational world. If people would pay more attention to what's actually produced, in this operational environment. You get a lot of research done off of that material, as we've shown from my perspective, but the insights that one gathers from their experience is really phenomenal. And again, we had a number of people come through Wisconsin when I was a student there. Dennis McCarthy is one of them. I didn't know anything about the cold air damming or that was going on. He was working on that in Wisconsin for his master's degree, and I was looking over. I didn't think the Appalachians. What would I know about the Appalachians, right? Having that much influence, they're the small mountains, right? Now, I've been living here for 42 years. The Appalachians drives practically the whole, I would call it the micro to meso nature of what goes on here. I was first introduced to that by, Dennis, who, actually wound up being a regional director and then a director of OM, the operational meteorology, or AQUIS, that was derived from there. So, it was people like that coming through that I got to know, and we became good friends.
The lady drinking out of the pink sippy cup over there would agree with you about the Appalachians, wouldn't you, Aubrey?
Oh yes, those Appalachians. And I've talked to Dr. Uccellini before about Hurricane Camille because of your work with the jet streaks. If you want to throw some insight on that,
well,
involved.
There's a book, I was reading When Heavens Roared about Camille, and it handles the two, basically the two storm systems, right? The one that hit the Gulf and the one that sort of disappeared off the TV screens and then reemerged over Virginia, and these record rainfalls, that it's just astounding how hard that rain was. Some estimates of up to 10 inches. You get these different extreme amounts of 5, 7, 10, maybe more inches per hour. And people not realizing, the people who lived in this area not realizing that when that rain, it was not forecast, obviously. People saw a weird sky with the sunset and these clouds coming over the mountains. But it was not forecast, and it totally wiped out that area, southwest Virginia, and then over towards the Richmond area. And what's really amazing about reading their stories is that their first realization that something was wrong, really wrong, was when they were awoke. They wake up and they're hearing this pounding on their roof, and they step out of their bed and the water is up over their knees. That's when they learned something was wrong. Okay, I can use that as sort of a benchmark of what happens when you don't have a forecast and you don't have IDSS, you don't have impact-based assistance support service. The sheriffs were out, they were just out doing their normal cruise and saying, boy, it's raining hard here. Oh, yeah, it's raining. And then they see a house floating away, all right? So how can you respond, or if you're not prepared, right? This is the kind of thing that happened. Well, that storm spun up in central Virginia, southwest Virginia, in the entrance region of a jet streak on a very strong frontal system that was actually coming down. And it was that combination. It was a perfect alignment with the entrance region of the jet. And as a master's student, and I always forget the name because never wrote the paper, but did his master's degree under Lance Bozart, that I heard about this from Wes Junker. You ought to look at the Camille, case. If you want to look at, tropical storm jet streak interaction. I didn't know this, and I looked at it, and then this master's student worked on it, and it was really an amazing, conjunction of events that just zeroed in on southwestern Virginia.
And
so
I have that thesis that you had sent me. His name is Matt Potter.
That's it. Yep. Glad you got it. You rescued me.
I did. Yep.
Because Lance would have my head, because I always forget it. And he always sends me another copy, and then I forget it again. But it's really a great thesis. And this book, by the way, catches on that alludes to the upper level circulation system being aligned just right. Gets into, mentions the jet. It doesn't get into the rising branch of the direct circulation or anything like that, but that's where it was, right? And it had the moisture feed just right, accelerated the low level flow that brought even more moisture into this as it developed, and it just crushed the area, just absolutely crushed that area.
I think you're right. That book does a really good job at balancing what happened in the Gulf Coast and what happened in Virginia.
Right, and how people try to respond, but they had information along the Gulf Coast. There was I think in New Orleans, I think is where this a TV and radio meteorologist operated from, had a lot of experience, and I'm sure James, you'll have his name. And
Nash Roberts. Yes,
yeah, that's right. And they had information, and there was this whole debate going on about whether it would go into that part or first go, towards Florida coming out of the Gulf. I mean, people recognize it as a dangerous storm, but where it was going to go, right? The old track problem and not having any numerical guidance or anything like that. Nash Roberts picked it up. So those folks had the information that a dangerous storm was approaching, but not 200 miles per hour, not a Cat 5 developing, as it was approaching the coast. And then so when the realization that was happening, it was too late for a lot of people, obviously. Some people were able to get up a little, out of the surge area. But no, it was a pretty horrendous situation. The thing in Virginia, that phase of the storm was just a complete surprise to everybody. I mean, it just took everybody by surprise. And you read the stories about what people went through and the losses they went through, and in terms of, obviously the survivors told their stories, but they were telling them about their family members that they lost. And it was really a pointed book, actually.
So Louis, I guess that Robert Simpson was the director of the Hurricane Center then, right?
Yeah, he was the one that was competing against Roberts. I
saw that even as late as the 1979 preliminary report on Hurricane Frederick. The Weather Service mentioned, or the Hurricane Center mentioned, the Nash Roberts problem, which I thought was an interesting way to put it.
Yeah. Well, the thing is, if you read the story about the Long Island Express, even before the Hurricane Center was created, you had this handoff to different sectors in the Weather Bureau, but the chief forecaster in that was considered like the sole source of information. So if you have analog techniques back then and you're saying that this is going to go off because it's basically the way things work, right? That posed a real big challenge, obviously, because the thing kept on not only going northeast but accelerating. By the time they even mentioned the storm would be storm force winds, but not using the word hurricane, was already making landfall on the eastern end of Long Island, and the news media in New York City had no clue what was going on 70 miles away to the east of them. Right. Mm-hmm. So that's the information void that people lived with back then when something like that happened. And of course, it had terrible consequences for 500 plus people along Long Island into New England. So, yeah.
So, and there was a little hurricane called Sandy that came along, and we ended up with something called a Sandy supplemental, which I thought was something we got from Vitamins R Us or something. But explain the impact that supplemental had on your job in the Weather Service.
Yeah,
now, Troy's moved into the center square now, so Troy, get ready to. We're going to ask you the hard question in a little bit.
Yeah. So the thing is, I was the head of NCEP at the time of Sandy, and we had there was a difficulty in forecasting that storm with respect to the track. And of course, the European Center's model run had it closer to the coast. The original runs had it running parallel up the coast, and the GFS had it turning out to the coast. The forecasters back then, and they did have access to the ensemble runs that we had. We had the NAIPS based on our Thorpex experiment. So Canada and the United States got together and saw that this was a predictability issue, not a model. In other words, there was this shortwave trough digging in, and if how you got up the coast, either ahead of that or after that, affected the track of your storm. Well, they saw tracks in the ensembles that were actually going out and then coming back in. And if you look at the medium range progs produced by these forecasters, they actually had the best scores. Now, what's interesting is that the European Center still had the first going out and coming back, but not going all the way out and coming back on a perpendicular angle. And that's, once we saw that, right, and the models were all coming together on that, then we knew this was about a day and a half out, that not only would it come on a perpendicular, which is the worst thing for a hurricane, because then you get the bad quadrant, on that, coming in right into the shore and coming right into like the bad quadrant was New York Harbor and northern New Jersey, right? So we really had to emphasize that. And Craig Fugate was the head of FEMA. He and I actually were handling the communications on the first round, trying to communicate this with a storm system that the models were suggesting was going to go extratropical as it was doing this and accelerating towards the coast. Okay. How do you message that? There was nothing in the because normally when this hurricanes are going extratropical, they're going out to sea. All right. And how they got handled was you gave them to the Ocean Prediction Center, or you gave, you had an arrangement with the UK Met, and you discussed the remnants of, the hurricane. And of course, there's been research since that suggests that it was still, had tropical characteristics even as it made. But this was the big debate about how to message this. This is where we really tried to focus on the impacts, whether it's tropical or extratropical. New York Harbor, you're in the wrong zone. You're going to have flooding conditions. You're going to have, and it turns out they had a record height on the surge. Northern New Jersey, you're going to be in tough shape, and people, so we did the best we could with the situation. And, there are people who claim that we saved lives. I believe we did save lives. Fire Island on the south coast of Long Island was totally evacuated. These are people that just wouldn't even listen to government, but when they saw and that we were and heard what we were doing, they got that evacuated, right? So the thing is, that was a tough one. Part of our problem at the time, we ran a course of resolution, et cetera, et cetera. I had computers that were, they were going up. We'd gotten some increase, but we were way behind computing capacity. With the Sandy supplemental, we were able to get finally up to what the European Center had for their one model. We were able to get for our entire model suite. And I was actually able to, we were able to implement the HER. For 5 years, we couldn't implement the HER because it wouldn't fit on our system. It was run on a research computer out in Boulder. That's where we ran the HER. So that supplemental, when you get a supplemental, it's added onto your budget, but it's only for 2 years. You only have 2-year money. You got 2 years to spend it. You don't have any maintenance tail on it or anything. So you really can only use it for things that you either need to buy or enhance. You don't put people on it because you can't pay their salary after 2 years. You have to have, base money to pay the salaries of your employees. So they really zeroed in. The NBM, the National Blend of Models, that the national development of that started with the Sandy supplemental. So what happened was, with the money, Congress asked for a team to go out and then come back and recommend what we should get. The big computer was one of them. There were some other things in there. Obviously, there were some stations damaged that had to be fixed. But things like the National Blender models to start that process of digitizing the forecast process, that started with the Sandy supplemental as well. So those are really important, and you see this now more and more. We were able to get the Hurricane Forecast Improvement Program and the hurricane model. Now that we get supplementals after some of the hurricane does damage, and we still have issues with intensity, as people see. We've been able to get money to develop that model, or to add on to it, or whatever. Use new observations in that model. So that's what the supplementals have done for us. And Sandy supplemental was the first one that really kicked it up.
So Louis, do you ever think back that maybe it would have been a different situation if maybe you'd broken a few rules at that point, or maybe superseded some policy? Do you look back and think maybe that would have made it easier on the meteorologists that were trying to communicate?
No, but well, you mean in terms of the communications? No, it wouldn't have been, because the connection with the emergency management community at the federal, state, and local levels were really set into not stone, because you do change them every year, but you do that at the hurricane conference. So if you started messing around with protocols or how you message it, isn't that at that point, it isn't like, hey, we're trying to make ourselves look good. It's, you were trying to keep this communication flow consistent with the emergency management community. Now, we don't have, at that time, we didn't have the level of partnership that we have now. We've spent a lot of time practicing with emergency managers, working with emergency managers, gaining their trust. We're invited into their space. They're the ones who are making the decisions whether to evacuate people or not. They're the ones, working with the first responders, like in Texas, when the hurricanes make landfall, they look for the eye. You can go out there and get those people who've been calling in, but you got to be back in 45 minutes. I mean, all this is happening on the ground. We're invited into their space, right? And the point is that if you got something set up, you don't change that on the fly, okay? And you figure it out, and then you work through the winter on the next round. Okay, we got to change this. So it's sort of like the HasSimp. We're trying to simplify our messages. You just can't flip a switch on this, because you got to work with people who have worked off the back end of your systems, use their data, have set protocols, and you don't change that. And Troy will tell you the same thing with the aviation community, right? So you just don't do it.
So all the conversation about hurricanes and the nuances of communication that we're talking about, HasSimp has been this great, effort to try to simplify messaging. I'm so glad we have you on the show, because this past year I've been thinking of you really often. Sometimes we're trying to communicate into a communication ecosystem that has other risks that they're contemplating, even when we have, for example, this incredible record hurricane year. Can you give us a little bit of insight into what this past year has been like on the messaging side? Were simple messages even possible? And what kinds of partnerships did you need to formulate to get through hurricane season in a pandemic?
Well, where do I start? We're almost at year one, working within this environment. Let's start with the last part of your question, comment. Very early, we saw within headquarters and out in the field that we actually didn't wait for a policy on how to adjust to this. So if we had a mantra of mission first, people always, we flipped that. It was people first, mission always. So what happened was we have a chief operating officer now, John Murphy, who was on the horn with the regional directors who were getting, ideas from individual offices on how to, do this. We can do a lot of our stuff from home. Okay. You only need the warning part of it you got to do from the office. But there's a lot. So we started going into this 2-person attendance in the office itself, and then offloading work to people at home. So we had to do a lot of rapid work in getting PCs, getting authorization to do that for some of the products and services. But we went there. And then on shift changes, the idea up front was you don't connect on shift changes, that there were offices, you have about a half hour overlap, and offices were, phoning the people in their cars about what was going on rather than being, over the same. And then they would leave on one door and the next 2 would come in on the next door. So there was and then we're always washing down, so we were doing this and seeing that we could sustain. Now, if you get into a severe weather environment, you need more people in the office, but they had criteria for doing that as well. So April was a very busy severe weather season. We worked with CDC on messaging for people going into shelters. So we had we have a partnership with CDC. We got all CDC. How do you message this? Because now people are going to be forced together, right? There was a situation, I think, in Texas. They got a mobile home park. They all went into their shelters. They came out. The whole mobile home park was wiped out. They hadn't gone in there. All right. This was one of the when we had that whole string of severe weather outbreaks. So in terms of operating, we did that. All training was virtual. Most of the headquarters work was virtual. Reporting out, up and in. But there's a presence. One of the things that we say was we weren't closed, right? We were never closed. So even there were offices that had the problem. The offices had to be clean. Instead of just having a primary and a secondary backup, we had primary, secondary, tertiary backup. The new AWIP system allows much more connectivity amongst the offices. So a lot of that was built in. With respect to the hurricanes, then you're dealing with an emergency management community that's also adjusting. So one of the things that got us through was the very close partnerships, the incredibly close relationships we've had now with the emergency management community at every level, federal, state, and local. This was critical to have this in place because, as you know, it's an intragovernmental issue to react to a hurricane. FEMA prepositions, helps coordinate where they can. Some states, coordinate, actually make decisions. Other states, it's all the decisions are made at the local levels. So it's you see examples where a state wants a city evacuated and the city says no. Think Houston, right? And they've sort of, the flooding was going to be so big that they had to, they felt like evacuating wasn't practical. They just want to know where the dry ground was going to be, and then they prepositioned assets there and alike, and big trucks, and then went in and rescued people that way. So you've got to work with their operational procedures, and you got to understand their key decision points. And that's what we've been working over the last 8 to 10 years to do. And we were positioned with a trusted relationship to continue doing that virtually, which is why it worked. And then the messaging part of it is, this is a work in progress, and it's not easy. I tell folks, you think the physical world we live in is complicated, non-linear? Try human factors, right? This is a real. Some people respond very nicely to certain messages, others don't. All right. How do you give the emergency managers the information that they need to go out and last ditch effort to get people to evacuate. You know, so we've been working with them, and it really paid off this year. I really feel very strong about that trusted relationship at the intragovernmental levels. You still saw the same consistency of actions, the same collaborative partnerships working between the Weather Service and emergency management at every government level. And I thought the response to Laura was phenomenal. You know, there were challenges there, even with that great track forecast. You know, you don't verify a forecast with a forecast. So during that period, there were some models that were doing some stuff, you know, off to the left and off to the right, and we focused on Louisiana, and the emergency managers made some tough decisions. Again, Houston was on the verge of evacuating when there was, you know, in Javier talked about this at the NWA conference. There was a couple European center runs that went off to the left, and people saying, "Oh my God, it's the euro." You know, the co-location of our forecasters with the emergency managers at that time is what kept them in their seats and allowed them to, let's go through a few cycles before we do this. And then, you know, everybody saw it was going to go off into Southwest Louisiana. And that was important. I think Dorian, you know, one of the big stories that got missed in Dorian was Miami not evacuating. Think about this, folks. A Cat 5 sitting over the Bahamas for what, 36 hours, and they didn't evacuate. They trusted us, and that relationship. So it's and the communications aspect. It really depends on. I still think it boils down to knowing the key decision points and knowing what you have to say to either trigger the action or to hold the action. When you're working with the emergency management community. But they have their key decision points, and they make the final decisions with respect to go, is it worth the risk of not going, you know, not responding, versus responding in the forecast, you know, does something else. We have all kinds of discussions like that. So that's one challenge. The other challenge is, what do you do with this? Right? Because with this, everybody's a decision maker, right? People have a cell phone now. They can shop around. We work with our media partners. James knows that. Everybody who works with us, we try to get you on the chat. We're if it's collaboration, we got to listen too, right? It's not one way. And because, you know, when it comes down to the bottom line, a lot of people are making decisions based on what they get on these devices. And that's much more of a challenge, obviously, but social media has also been a blessing in getting the information out as well. So, and getting information to us. So you just have to work, through this. I think our partnership with the media has improved. And certainly it's improved since the 90s, and over this period of time, because I think everybody's realizing how important it is to get you know, messaging out, and so people take the right action. I think that's the key thing. You know, how do we message this collectively as an enterprise, as a total enterprise, to get the right message out? Because you want people to take the right action, and we still got work to do. But I think we're in a better place now than we were 10 years ago.
So you mentioned Hurricane Dorian, the amazing forecast that the Hurricane Center did there, but we suddenly were plunged into, you know, a huge controversy just on the back of a Sharpie. Louis, talk about how that made life difficult for the Hurricane Center.
Well, I know the people in the forecast offices, the Hurricane Center, the Birmingham, and other offices were very upset. You know, there's been a lot of reports on this, and you know, there's a scientific integrity that we apply, not just to people writing papers. Okay, we apply it to the forecast process as well, and to people who make it happen. And and they have a they have a responsibility. And in all my years in the Weather Service, even when I was working the floor at MOD, I never told a forecaster what to do. If we had a discussion of the meteorology, I'd certainly offered my opinion. Okay, now walk away. The point is that the folks who do this day in, day out have that trusted relationship with management above them, right? And they felt they lost the trust, and that was still coming on me. And James was there. I talked with him before I gave my speech, just defending the forecasters because they were doing their job. And the thing is, that's history, right? The other part of Dorian was it was a tough forecast. That was a tough forecast because, again, early on, there were models running that storm right across Florida, right into the Gulf of Mexico, right? And then from there, it was all over the place. One of the things that it also not really, and I'd love to say, I haven't seen the sensitivity studies, but we started launching balloons, the supplementary balloons from forecast offices, not only around the area in the Southeast U.S., but I was talking to Neil, on the phone. I said, I want to get those balloons up. I told him, I said, we're making this. I want to get the balloons up along the northern border of the U.S. because it's the westerly waves, whether it's going to pick up the storm or not. That's the real forecast issue here in terms of whether that storm's turning up the coast or going into Florida and maybe even going into the Gulf of Mexico. When we started those extra balloons at 18Z and 6Z, and Canada joined in, by the way. We have a nice relationship with Canada. They were launching balloons up there as well. Not every model run, but the ensembles all started turning that sucker up the coast. It was interesting. If you look at the model runs before we launched the balloons and the model runs there. Now, I haven't seen the with and without balloon runs, in this. So it's hard. You got to show that, right? You got to go and do the work, as I like to say. We haven't done that, but we all kind of noticed that there's more consistency. In fact, some of the storms that would go way out, the consistency was to pull them back into this envelope of solutions, and then but they quickly did, and so that's why the confidence was high on that Sunday. By the way, that this storm was going up the coast, and it was high enough that Miami, don't evacuate. The working with Florida into Georgia with the local and state emergency managers, phase your evacuation. They had this whole mapped out for phasing based on our forecast track, so they didn't have a Floyd. Floyd was a disaster. Everybody evacuated at once, right? So they phased it very narrow areas along the coast, and then North Carolina, right? South of North Carolina did the same thing. That's a remarkable story of coordination between what we do and what the emergency managers do. And it's all based on, basically 10 years of working together like this. And it paid off. It was really, really tremendous what happened there with Dorian and how the evacuations were managed up and down the coast.
So that, Louis, we promised a state of the union of the National Weather Service tonight. At least Jen did in her excellent social media post today, because that's what I told her to do. And I've only allotted about 16 minutes now for that process. So I know there's a lot of successes that have happened in 6 years. The service life extension program, dual pole, all these things are incredible. So, let's think about the accolades for a minute. I mentioned too, what else would you say you're really proud of?
Well, first of all, I'm really proud of this Weather Ready Nation taking off the way it does. And I'll say this here, I've said it at conferences, the field embrace of this is what's made it a success. We came up with a plan. Weather Ready Nation, we had a small strategic team back in 2010, 2011. We had field people on there. I was on there as the lead as the NCEP director. Bill Hopkins was there as the the deputy of the union of Nuicio, the vice president, I guess, the vice president of the union. We all saw this as fundamental, that we needed to do this, go beyond the forecast and warning, that if we were just doing forecast and warnings, if that was our hedgehog, as the expression was used at the time, we could be out of business in 20 years, right? So we, came up with this plan, and to go, beyond, connect with decision makers, impact-based decision, and it's working. A lot of it has to do is that the field's embraced it and are running with it. What's going on in the fire community, dealing with the fires out in the west, the hurricanes, the flooding, even the snowstorm is a difficult forecast issue for the storm's still going on. The connection with decision making is such that you don't see the finger pointing, because people understand the level of uncertainty you're dealing with as you work with them. It's really been great, and the field's been a really, really doing that. The NextRad, you mentioned the NextRad SLEP, we're still working that. And, we got the transmitter and the receiver modernized. We actually get faster scans now, so you get quicker returns with that data for the warning process. We added something like 2 or 3 minutes to the warning process itself if you were waiting for the next scan. And it's easier to manage and maintain with the new hardware in there. Now we're doing the pedestal, right? The bull gears, et cetera, et cetera. We try to, we'll have this system. We got the new generators. Everything will be new, rebuilt, and it'll get us into the 2040s. So phased array's coming around, but it's got its challenges. It's got a lot of promise, but it's got its challenges. We got to work that carefully. We now have a system that's really, that'll get us to where we need to be in the 2030s to 2040, and then the phased array hopefully will be around even before that. But we've got this window to work with. The computers, we just got our next contract, the 10-year contract. We're going from 4 petaflops to 12 per system. That's going to set us up for the next decade. Obviously, there's a built-in increase into these contracts now, so really happy about that. I know we're having problems with our dissemination system, and I'm not going to run away from that issue. But the fact is, we didn't have a dissemination portfolio until 2015. We didn't know how much money we were spending on dissemination. We didn't have a central system that could get the data out. We had low bandwidth in forecast offices that employees had to do work at home, their training at home, because the bandwidth in the office wasn't. If GOES are, that data hit those old, we had regional systems, we didn't have a central system. If GOES are would have hit those dissemination systems, we would have taken it down. You wouldn't have gotten GOES R data during the engineering checkout phase. So we built this one weather service network. We increased the bandwidth to all forecast offices, including the CWSUs. Mission impossible. We got it done. Okay. We work to get the applications into a virtual world. We have now a primary center in College Park and a backup center in Boulder. And therein, we started hitting the problems because some of these application software systems won't run on these new systems. So we still got a legacy system, in Kansas City. So we run into problems with systems like chat because the demand, and that's the other thing is, now that we're managing these systems, we can measure the demand structure and all this. We anticipated an increase in demand for our products and services and our model output, which is also now being distributed through this. We underestimated. And I got to tell you that demand for our model output is and the ensembles especially, are way above anything we imagined, right? So now we're looking into, we finally got a plan up to the hill. We got approved through NOAA, worked very carefully, working with the cloud approach, both commercial and internal cloud. If you're going to run a system 95% of the time, why pay the egress costs or anything like that? So we're working that, and we're going to move this forward. The point is, there's a lot of pain here in this change. We had a lot of pain when we got the primary and backup computing systems in the early part of this century for their models, and that's working really well. But so we're working those issues. The Epic is something that came with Neil Jacobs. We're embracing that. I look at this as a golden opportunity to get our models out to the research community in ways that we couldn't even imagine 5 years ago. And now we're positioning ourselves with a unified forecast system, cleaning up our model suite, and building up the model capability. And through this, and we're going to engage the larger community, not only with respect to the model, but importantly with the data assimilation system, which I think is where probably our biggest weakness actually is in the whole model system, is probably in the data assimilation. So we're really focused on that. And the last thing I'll mention, I've basically covered all the portfolios in our budgets, including analyze, forecast, support, which is the collaborative forecast process, and the amount of collaboration that's going on between the centers and the forecast offices, and the river forecast center and the water center, and all of these getting together on these critical situations is something I'm really proud of, because this is, I think, a signal of the buy-in from the workforce in terms of what they have to do for consistency as well as accuracy to make this information actionable. We're also, the last thing I'll mention is where we have the opportunities to co-locate, we are co-locating. And the next big move is in Albany. The Albany WFO is on one side of the campus. On the opposite side was the department. They're building a new building that will have that department. We'll have a college of emergency management, homeland security, and cybersecurity in that same building. They'll have their research lab in there. They'll be managing the state Mesonet out of that building. We're going to be in that building, okay? And here's the twofer. We're right across the street from the State Emergency Operations Center.
Wow.
All right, right across the street. So all those practice sessions that you may or may not get to, or that interaction, they want co-location, they want you to come over. It's literally a 4-minute or 5-minute walk across the street. And that's the kind of connectivity we need. Academic research, right? And with our core partners on the other side, which is decision, how do we connect with decision makers, is all going to be right there. So we're pretty excited about that. And we're actually, the Weather Act and other language and appropriation bills have told us take advantage of co-location because it helps us reduce our physical footprint. And we can work closely with our core partners on the front end, research and education community, now in emergency management and meteorology, and on the back end in terms of decision makers during events, right there. So things like that really proud about, and I think it's making for I'm sure it's making for a better weather service, and I also believe our connection within the enterprise has strengthened during this whole thing just by looking at the number of Weather Ready Nation ambassadors that have come out of the enterprise and how we work with them as true partners to try to advance, the whole meteorological enterprise. So that's happening now too, and the power of that shouldn't be underestimated.
Unmute myself there. I know Troy wants to ask a question about one of the portfolios. Talk to us about how much more pain we'll have to go through till dissemination smooths out.
We had a plan that we again worked through NOAA very constructively, department, OMB, up to the Hill. we are seeing movement in terms of resources directed towards that plan. That's about a 2-year planning process. In the meantime, we're working to enhance the capacity and the ability for maintenance and personnel to do that. So, we had the 3-pronged plan was to stabilize, chat, right, and how we managed it. So we do, especially towards extreme events. These things work fine until you get an extreme event that involves a lot of people. No surprise. We saw the same thing, with the Hurricane Center way back in the 90s and the early part of the century. Once we went to the internet, the demand goes up, orders of magnitude during these events. Anything along the East Coast knocks up. The fires out in the West, floods in the Midwest, right? Hurricanes along the coastline. So we're trying to gear up for those peak periods that are larger than we anticipated, right? So we're doing that, and then we're already experimenting with cloud techniques, getting things on the cloud right now, and we're certainly looking into that commercial for the research and perhaps the research to operations cloud type environment, and even for some of the operational aspects too. So we're looking at that, and I'd say like a smart cloud approach is something that I think is probably the best way to characterize it. So it's going to take time because you got to run systems in parallel. You got to test, you got to make sure, and then you got to cut and run with the new system, and that's all being worked out. I think there's going to be some pain, but we're certainly attempting to mitigate that and to now accelerate our efforts with the resources that we got. So,
Louis, Troy here. I want to thank you for joining us tonight. I will tell you that one of my proudest moments in my professional life came a few years ago when Ken Carey and myself here in Austin worked with the AMS president at the time, the incoming president, Dr. Louis Uccellini, as chair of the AMS at that meeting. A gentleman, Louis and I have always had a great relationship. He's always been there. I don't try to bug him too much, but at the same time, I have a lot of respect for Louis and everything that you've done. And I want to ask you something that's kind of related to Ken, because we had Ken on a few shows back. He is a deputy for the ASOS program, part of the National Weather Service. And that one, Louis, is just sort of a strange one anyway, because the Weather Service is no longer responsible for weather observations at airports. That is largely, it was decided to be something that the FAA would kind of take in there. But of course, the Weather Service, DOD, and the FAA are involved. It's kind of a tri-agency effort. But I'm kind of wondering what you think or what your thoughts are. And Ken kind of explained this to us a little bit about where we go with the ASOS. Just getting a little bit older in the tooth. As time goes along, what's your gut feel, even though I guess largely, Louis, you're not really responsible for it other than maybe advisory to some degree, right?
Well, the ASOS is a tri-agency program, just like the NEXRAD is.
Right.
And the agencies have responsibilities for their units in terms of the procurement of those, but we actually maintain the system for all agencies. So for the NEXRAD SLEP, we're actually the same group of people who's changing the transmitter and receiver are all doing it for us, doing it for DOD, doing it for FAA. So we're now, I would have loved to have done the ASOS SLEP at the same time we were doing the NEXRAD, but the funding profile for the NEXRAD SLEP was pretty steep. So as that came down, we're now ramping up the ASOS SLEP. Okay. And with that, I have to look at my notes because, I just want to make sure I get the parts right, because I know that the, you folks, Bill will probably say that's not what it's called, but this unit, the acquisition control unit and the data collection package, this had software designs and systems, right, from the early to mid 70s.
Yep.
Okay. So people want minute data. They want the data every minute. You got to take care of that unit. You got to replace it. So that's part of the ASOS SLEP already. We're actually looking for bids on temperature and dew point sensors. Okay, because we know we've got issues with the specs for temperature sensors was driven by aviation requirements during the modernization. Okay, so now there's obviously a tighter, there's more attention, right, to this. So we're looking at that. Ceilometers, I think the ceilometer's already been changed out in a number of the areas, so you can see up 20,000 feet instead of 10,000. Why is this important? All right, so back in the modernization, when you could only see up to 10,000 feet, and we were launching the satellites with sounders that I worked on at NASA Goddard, we wanted to keep those sounders looking out over the ocean, so you could actually sound with a black body underneath the upwelling radiances, so you have half a chance to extract the temperature and moisture information. We had to focus it over land to get the cloud heights above 10,000 feet. Okay, so things like this are being addressed with ASOS. I want, and with this ACU DCP minute data.
Yeah.
I've got emergency managers that are asking for minute data, much less the meteorological community that comes at me like, when are you going to get minute data? I mean, this is the only way, like the whole gravity wave issue we're talking about. There's a group of people, I belong to the Gravity Wave Underground, right? Anton Seaman and the group, we're starting to see
show title, by the way, the Gravity Wave Underground.
Yes, I love that, right? So the thing is, the numerical models today actually have these waveforms in them, right? When I was doing gravity wave studies, the modelers didn't want to talk to me literally about it because they were filtering all this stuff out, because that was the only way you could initialize a model back then, right? So the thing is, we get alerts. Hey, this system is setting up. There looks like there are indications of gravity waves, and then we actually look for. There was a lot of wave activity in this system we just had, right? You could see it in the cloud structure,
right?
But you don't have a chance of isolating that gravity wave mode if you don't have wind data and pressure data at same high temporal resolution, right? Because it's all a P prime U prime kind of equation that you're looking at. It's the perturbation of the winds and the pressure. And that relationship that defines it as a gravity wave or not. Okay, so you got to have at least minute data.
Yeah,
and it's got to be it's got to be calibrated right, for pressure and wind perturbations. I mean, we're talking. So this is the kind of things that we're looking at and thinking about. We get a lot of interaction with Lance Bozart and his team up.
Yep.
Admire that. He's older than me, but. So when I feel like I'm getting old, I just look at Lance and say, got to keep on going, got to keep on going. But
any hope, Louis, on the one thing I've kind of looked is that the present weather sensor in the ASOS, just because we have AWAS units, which are lower costs that are showing us drizzle, and our ASOS is still by themselves can't distinguish between drizzle drops and raindrops. I'm just hoping that present weather sensor is in there as well, maybe.
Yes, we are. Yeah, the present weather and visibility. Actually, we're considering that. We're still working on the resource. You get a certain depth of your resources for all of this activity, and then you got to figure out what's going to wind up above the line and what's going to wind up below the line. So, but we are, looking at that, and the all-weather precip accumulation is another thing on the list that we're taking a look at.
Thank you.
So that's the, we're trying to get these observation systems, on this, and there's a lot of technology out there now. I mean, every time when we were at the AMS conference in person and seeing this, what's going on in the observation world, the in situ world, and then remote sensing from the ground up world. There's a lot of things out there that we need to take a look at.
So Louis, I got to ask one question. So a week ago, when we finished the show, we had an EF3 tornado here.
Right.
It killed one person and injured several, and it was a rough night. Something happened to WEA. I don't know what. There was a failure. All the carriers, it just didn't work. Weather radio was crucial. In the SPC tornado watch, 4.5 hours before it happened. The lead time on the warning was 8 to 10 minutes. 10 years ago, there never would have been a warning. It was a messy, convective situation. The Weather Service did an exemplary job, but weather radio was crucial that night. My question to you, what's the future of weather radio?
So weather radio is in the dissemination portfolio. There are estimates, different estimates, of 30%, 35% people still rely on it. And of course, we've just gone through a major upgrade of the towers, and the digitizing systems. We continue to do that in coordination with the weather radio, the radio producers. So I think weather radio is a key part of what we do, and what we need to do now is to ensure that we have a way of broadcasting, because that's the biggest challenge with respect to tower space getting so expensive. Used to be people volunteered space on their towers, lease space. That ain't happening anymore. Nobody's giving that away for free. So we're doing that. It's a very important part. With respect to WEA, we have that system. We have a primary dissemination system in College Park. We have the backup in Boulder. The WEA part of it goes through there. We had to shut that system down because of one of the electric switches. The primary electric switch for the whole thing had to be replaced. We had to do it, and you got to shut it down. You got to line up a lot of different people to come in and do that job, and that's what happened to WEA, unfortunately.
And again, we stress, we all stress in messaging. You've got to have two ways of hearing a warning. Two ways, the baselines of weather radio, and then you've got your phone. So again, I think it worked well. One more question. Is there any plan to make weather radio storm-based as opposed to county-based, which it's been for
so part of that, this was one of the first questions I got in the very first International Association for Emergency Management meeting I went to as the director. In 2013, this was the first question I got. We had to digitize first to be able to do what they wanted to get it to, smaller zones, right? So, and obviously out in the middle part of the country in points west, the counties are much larger. So, to say you're doing countywide warnings, the false alarm rates obviously are not helping you, right? So helping us. So the thing is, we do see that we are making progress. We are finding communities to test it, and it seems to be something that we're going to pursue. So, but yeah, it's really important that we can hone in and help reduce that false alarm rate, because that's the thing that's really was really working against. There's a lot of things working against these broad areas. I mean, obviously, but the false alarm rate is a critical part of that.
Right. And I promise we'll let you go after one more question. A lot of young people listen to this show, and these are high school students. They want to be a meteorologist. They're ready to go to college. They're seniors. They want to work for you, the National Weather Service. What advice would you give an 18-year-old?
Follow your dream. Number one, it's your journey. Okay, everybody has their own journey. Everybody has their moment when somebody taps them on the shoulder and you don't know why that happened, right? I mean, I could talk about 2 or 3 things that happened to me that just changed the whole vector. So it's your journey. Follow your dream. Number one. Number two is when by the time you get through, I didn't know. As a child, my parents didn't have a lot of money, and neither one of them went to college. You relied on your counselors in the high schools. They're a lot better now, especially directed towards physical sciences like ours. There's a lot of schools out there. Find one that's right for you. The second thing is because you got to feel good when you're going through the school, and you got to feel good about the place you're in. And it might be, that you want to chase tornadoes. It might be you want in the middle of the Southwest droughts and then study the monsoons. A hell of a lot of people want to study that Southwest monsoon. You find your place, and in work. And the other thing now is, it's not just the meteorology. If you want to work for us, it's not just the meteorology, the hydrology, space weather. We got the sun to the sea, right? It's incredible domain space, and from Guam to Puerto Rico, a third of the northern hemisphere area. Okay, so it's tremendous challenges all across there. You want to work with indigenous people, you want to work with tribal nation, you want to work, so all of this is part of what we do, but it goes beyond the forecast and warning. So the universities now are giving more in social science related to what we do, emergency management, meteorology, joint degrees. Look into that. Okay, that we didn't have those kinds of connectivity when we were going through school. But you got to have a solid basis. You got to have a deep knowledge of how this atmosphere is working, how it's interacting with the other Earth system elements, oceans, land, cryosphere. You got to know all of that. And you got to know how to get it out if you want to get in the weather service to actually affect a decision. And that's basically where you realize the mission of the Weather Service by doing that, okay? It's not just making a forecast and warning, it's getting it to the decision-making and affecting that decision. So you got to bring all that to the table. And if you really love what you're doing and motivated by, you always wanted to be a meteorologist and take this, you'll wind up in a good place. Now, the Weather Service has really gotten very competitive until we get about 200 applicants.
That's the main thing, because how can you put yourself in a position to get a job when you've got 100 others looking for the same job? So
there are these summer camps, these summer programs. There are now programs in which we run, other components of NOAA run, that get you into a NOAA lab, get you into get FaceTime, as I call it, so people get to know who you are and what you can bring to the table. That's a very important part of moving up the curriculum. For researchers, it used to be going to conferences was it, man. I didn't realize going to a conference was your job interview. It turned out for me it was. So
okay.
Anyway.
Yeah. All right. So we're going to take a quick break, and Lou, if you can stick around for about 4 more minutes, because we do have picks of the week coming up here in just a second. So we're going to break for Tony Rice and his report on astronomy. We have Jen's This Week in Tornado History. We will come back with the weather roundup, picks of the week, and more as WeatherBrains rolls along.
Looking beyond the atmosphere, here's Tony Rice with your Astronomy Outlook.
A paper published last week in the journal Nature may provide a possible answer to a long-standing mystery about the Holocene era and its impact on climate. The study describes new methods to estimate historical temperatures that suggest that the last 12,000 years were actually much cooler than current interpretations of the models might show. The paper points to greater swings in temperature between the seasons caused by changes in Earth's orbit. You see, there's several components used to describe an orbit. One of the most important is eccentricity, and that describes how circular the orbit is, using a number between 0 and 1. 0 is a perfect circle, and the bigger the number, the more squished the orbit is. Earth's current eccentricity is 0.017, but that can vary. This was first described by Serbian scientist Milutin Milankovic, and also described changes in obliquity, or Earth's axial tilt, as well as changes in precession, or the direction that the North Pole is pointing. These changes are a strong driver in Earth's long-term climate, and have been responsible for triggering the beginning and ending of ice ages. Earth is currently near its most circular path, but that eccentricity is increasing. The current 23.4 degree axial tilt is about halfway between those extremes. It'll reach its minimum in 9,800 years, and as that obliquity decreases, the seasons will grow milder with warmer winters and cooler summers. This is, of course, describing very long-term climate. Based on studies of sediment core taken from the seafloor by Samantha Bova, a paleoclimate researcher at Rutgers University, and her team, long-term climate variations line up pretty well with the seasonal changes in sunlight that are described by that Milankovic cycle. The study provides evidence that the discrepancy between the models and previous climate data is based not on the models themselves, but in how the underlying data is being interpreted. They specifically point to those more intense summers and not hotter overall years. The bottom line is that this proposed astronomical answer to the Holocene temperature conundrum is that Earth is hotter than it's been in the last 120 centuries, with that trend continuing. That's your Astronomy Outlook. Follow me at RTP Hokie for more spacey stuff like this.
The Super Tuesday outbreak started during the evening of February 5th, 2008, and continued through the early morning of February 6th. A total of 24 tornadoes occurred on the 6th. 2 EF4 tornadoes crossed through parts of northern Alabama. This week in tornado history, we look at the EF4 that occurred in Lawrence and Morgan counties. Per the National Weather Service Huntsville survey, the maximum winds were estimated at 170 miles per hour. This occurred in Lawrence County. The tornado developed near the Pinhook community north of Bankhead National Forest just after 3 a.m. Central Time. The tornado tracked 16.7 miles. It ended 3 miles southeast of Caddo in Morgan County at 3:20 in the morning. Numerous homes received significant damage. A 2,300 square foot 2-story brick house was nearly leveled off its foundation. Large trees with diameters up to 4 feet were snapped and uprooted. Fence posts embedded in concrete were ripped out of the ground and tossed 50 to 100 feet. A truck was thrown over a distance of more than 100 yards into an open field. In our summaries at tornadotalk.com, we try to capture the names of those who were lost during these tornado events so we can honor their lives. In this tornado, 4 were killed. Greg and Becky Coleman and their 19-year-old son Garrick were killed at their home in Aldridge Grove. In the Fairfield community, 86-year-old Faye Nell Long McCulloch was thrown from her mobile home. She died at the hospital later that night. 24 people were injured during this event. Do you want to learn to analyze and forecast? Join Tim Vasquez at Forecast Lab, airing most weekdays on YouTube, covering current weather, forecast techniques, and random topics. The address, youtube.com/forecastlab.
It is truly amazing what Tim packs into that 20 minutes, 5 nights a week. He was talking about Asia and Russia and covering the Western storm as in its incipient stages at a high level this week. So make sure you catch Forecast Lab when you get a chance. Picks of the week. I'm the one that, just let this 747 blow right past the end of the runway here tonight, Nate. So I will start with you. Picks of the week, and you have something important else that you want to add, I think.
Actually, I'm going to defer to Kim on that part, but I want to mention that this is the first day of Black History Month, and meteorologist Monique Robinson is doing a Twitter thread over the next 28 days to highlight accomplishments of notable Black meteorologists. And the first one she picked, maybe a little home cooking here, but our own Janice Huff from WNDC in New York City, who's spent most of the day today covering a pretty significant snowstorm up there. So it's my president's message for the NWA newsletter is going to be talking about Black History Month from a little bit of a personal angle on my end. And I think it's important that we, highlight and recognize and see, these people representing that you can do this, that anybody can do this. And it reminds me of a talk actually that Janice gave at NWA the last time we were in person in Huntsville about how important it was in her career to have representation and mentors and everything. So I will highlight that tweet over the next 28 days in that Twitter thread and those folks over the next 28 days.
I'm so glad you covered that, Nate. This is an important date, and thank you for bringing that up. So, Nate, did you have anything else you wanted to add before we move along? That's good.
Nope,
all right.
Good. This has been a great show, and I appreciate Louis being here. Thank you.
Outstanding show. Jamie's volunteered you for 10 more shows, Louis. So we'll get back with you on that. Dr. Kimberly Cloco McLean, I know you got a pick of the week for us.
I do, and I guess I'll follow up from Nate. He and I both being, communication oriented in this field, both share appreciation for some of the same researchers that influence our area of the discipline. And this name is actually going to be someone who's probably familiar to a lot of meteorologists because his work is foundational in some of the warning operations courses that WDTD offers. But I have to report some sad news on the passing of Dennis Milletti. He was the director of the Natural Hazard Center for a number of years. And foundationally has just taught us a whole lot about how people respond to warnings of various kinds. And I shared a small piece that I feel like he wrote a lot of books and articles, and you can find his content everywhere. He wrote an entire series on risk communication for FEMA. If you want to look that up, it exists online. But this is a succinct little piece that offers some really important insights into human behavior. It's a quick read. Some of his sort of, passionate, these are myths of human behavior that are so pronounced in fields including meteorology, and they just need to if we just think about people as they really are, we can serve them better. So we're going to terribly miss his presence in our field. He's a giant, and what's really devastatingly sad about it is he actually passed from COVID-19. So he spent his whole career trying to help people to mitigate the effects of disasters. And this was one disaster he himself could not escape.
Just another star in the firmament that we've lost this year. So due to this terrible pandemic. Thank you for that, Kim. Jamie, I'll hit you up real quick. And as we go through lightning round picks of the week here.
Yeah, no, happy to. So I just want to give a quick shout out to one of the National Weather Service teams I'm on is the Virtual School Talks, or National School Outreach Team. This is a team that you've had on your program before, headed up by Tim Bryce. And boy, he started this up well before the pandemic. And is this a valuable tool that we're all getting to know now? It's been quite incredible, the amount of virtual school talks that I've been able to take part in, including even talks this year all the way out to Beijing, China, and even a couple of Canada schools outside of the normal United States schools. So it's a great way for educators to get a meteorologist in their classroom, and boy, this virtual environment's calling for it. So more information, go to weather.gov/EPZ/education, and there's a lot of information there, including how to sign up your classroom.
Outstanding. Thank you for making the show happen tonight, Jamie. We appreciate you very much. Troy Kimmel.
Real quickly, we're very proud in Texas. James talked a little about the WEA incident. The technology, as Louis and Jamie and everyone else here can tell you, occasionally will get you in trouble. And my pick of the week is from KSAT TV in San Antonio from Friday. And I'll just read a couple of lines here for you. Oops. Texas Department of Public Safety issues an Amber Alert for Glenn Ray and Chucky from the Child's Play horror films. Now, I would only do a public service for you to tell you now that according to that alert that the Division of Emergency Management sent out in Texas, Chucky was last seen wearing blue denim overalls with multicolored striped long sleeve shirt, and he was wielding a huge kitchen knife. So we've done our public service here on WeatherBrains tonight, and there's one from the state of Texas for you.
Only in Texas. Thank you, Troy.
Exactly.
Aubrey, what you got for us?
So my pick of the week is some drone video from Sunday morning from two storm chasers with LSM, Brett Adair, and Chris Jackson, who happened to drive through the area, make a little pit stop, and take some beautiful drone video of our snow on Sunday morning. Most of our snow was really done before about 11 a.m. ish. And then we've just been kind of getting residual half an inch here and there. So beautiful snow. Did you see NWS post some great snowfall totals, highest numbers per state, 30 inches in New Jersey right now. And then a very odd story from Pennsylvania when police say a shoveling dispute left 3 people dead.
It's not good, Aubrey. It's not good times. So
very sad.
Thank you for sharing that. Jen.
So mine also has drone footage. It's an article and also has damage images from the atmospheric river event from the latter part of last week in California. And it's the loss of part of Highway 1 south of Big Sur in California. Some pretty dramatic photos of just what they were dealing with at the latter part of last week.
Yeah, Jen, you mentioned you have to buy some more books. You got to buy these 2 right here. I know that's what you were talking about. Louis Winter, that's my pick of the week. Louis, when are we going to have a 3rd edition of this?
Well, I got the outline right over here. Paul Cosin is derailed a little bit, but he's coming back, and we'll get going on it. It'll be we're going to focus on the 21st century storms and update, our I would say the climatology and the better insights that we have, not only through case studies, but also what the models are bringing to the table. Like that January 2016 storm is just phenomenal in terms of the consistency from run to run being physically driven. So we're working that, but
Louis, give us
it'll
your
take time.
give us your pick of the week. I know we got about a minute left.
Okay, yeah, I'm going to focus on the Heritage program. Our birthday is coming up, February 9th, and it'll be 151st. We had a big rollout for our 150th. So I know you have a link for the Heritage program, and what we're doing is trying to provide a virtual collection of stories that people want, that bring to the history of the weather, but also of the Weather Service itself. And to be around for 151 years is quite an accomplishment in and of itself. Brought prediction into science. This is what it did. So.
Yep. Well, guys, thank you all. Louis, thank you. What a great show.
You,
wow. We could talk for hours. You're the greatest. Louis, thank you so much.
Thank you.
We will see. I've got to run do some television here. I hate to tie this thing up, but we have to. Typically, WeatherBrains is every Monday night, 9 o'clock Eastern, 8 o'clock Central. If you want to send us an email, it is email@weatherbrains.com. We'll do a long email segment next week. And all the show notes, the picks of the week, all on the website, weatherbrains.com. So on behalf of the entire WeatherBrains crew, I'm James Spann. Thanks for listening. Have a great week, and God bless.
On behalf of the junior senator from Alabama, Dr. Uccellini, I want to thank you for your testimony.
Thank you so much.
Say, son, I say, yeah.